Welcome to Kojo's Pre-Algebra. This can be kind of difficult for some of you. I'm not going to give any practice problems at the end, so you're going to have to take really good notes and bring them to class because you're going to be working with your classmates tomorrow or our next class after our discussion to work through this. This is not in the book, this level, so bear with me. Okay, so adding and subtracting fractions. We're going to talk about like denominators and unlike denominators. First thing we're going to do is just going to review. When we add fractions, and I'm not really terribly worried about subtracting, because there'll be basic ones right now. But if I have 1/4 plus 2/4, what do we have to have when we add or subtract fractions? What do the denominators have to be? That's right, they have to be the same. So if they're the same, we just add them and simplify the fraction. So 1/4 plus 2/4 equals 3/4. Good. But now look, when we throw variables in there, it's still the same thing. Remember, when we have one problem and we have a variable, it stands for the same number. So even though we don't know what x is here, these are expressions, but we're going to put equals for now. Because we're simplifying, so just bear with me. I know I said don't use equals, but I don't want to confuse you. So here we have x and x within the problem. The only thing we know about x is that it represents the same number. So if it represents the same number, which it does, it's just like 4 and 4. We treat it like it's the same number in the denominator. We don't know what it is, but we treat it the same. So we treat it just like this. We say 1x plus 2x, we add the numerators, we bring it over, we only add the numerators. 1 plus 2 is 3, 3 over x. Just like we say 1/4 plus 2/4 equals 3/4. But when we have different denominators, and this could be 1y plus 2y, 1y plus 2 over y, same thing. Anything where they have the same denominator, xy is in the denominator, xy is in the denominator, they're the same, xyz, xyz, 2x and 2x, that would all be the same denominator. But if we have 1/3 plus 1/4, those are different denominators. So what do we do when we do that? We have to get a common denominator and then convert the fractions to the common denominator so we can add or subtract. Very good. But people always freak out when I throw variables in there. So let's see what happens. I hope you don't freak out, so I'm going to teach it to you. Let me see if I can pull this up. Going for the Lions game today. Woo, yes. Okay, so here, let's look at this one first. Here's the basic what we know. If we have 1/3 plus 1/4, we get the least common multiple that they both go into. The least common multiple that both 3 and 4 go into is 12. We don't want to just multiply 3 times 4 sometimes. Like if I had 5 and 15, we wouldn't say 5 times 15 and the common denominator is 75. We would want to get the least common multiple because it makes our lives easier. So if I had 5 and 15, the least common multiple is 15. So the common denominator for the new fractions would be 15, not 75. So look, we use 1/3 plus 1/4. And in this case, we're going to multiply them together because that is the least common denominator, multiple. So we're going to say 3 times 4. And I put this here so that you can see what your mind is doing automatically for you because that's what we have to evaluate. We have to process what our mind is doing for us, remember? And then we have to learn it a different way. So we have to map or to code our brains, if you will, to recognize new things and do it for us so we don't have to think about it. Because you just do this automatically. I have to remind you what you do. So we're going to say 3 to the 4th, so we have 12ths. So what we did, right? I shouldn't have done that. Is we say, okay, how many times does 3 go into 12? Well, 3 goes in 3 times with what left over? 4. And then you say 4 times 1 is 4. And then we say 4 goes into 12ths. How many times? Well, the 4's cancel, we're left with 3. Because 3 times 4 is 12, and 3 times 1 is 3. And then we say 4 plus 3 is 7, so the answer is 7/12. The denominator never changes. So look at this one. We have 1 over x plus 1 over y. X and Y are different numbers. We do have no idea what they are. We just know they're different because we have different variables. So if we have different variables, they represent different numbers. In the first one, when it was over X, they're the same number. We just don't know what it is, so we can treat it just like we did the first one on fourths. But this one, we're going to combine just like we did the 3 and the 4. We have no idea, so we have to assume that the least common multiple is X times Y, like we did 3 times 4 here. We have to assume that because we don't know what the numbers are. So we say X times Y, and our new, remember we shove anything together. We can multiply anything and shove it together if we don't know what it is. We don't use parentheses because X times Y is, yes, XY. So XY is our new denominator for both of them. So let's see where this came from. Same thing. Just like we said, 3 goes into 12 with left over 3 times 4. The 4 is left over, and then we say 4 times 1. We say X goes into XY with what left over? Well, the X's cancel, just like the 3's cancel here, and you're left with 4, and 4 times 1 is 4. X goes into XY with the Y. Think of these as the 3 and the 4. Okay? 3, 3, and the Y is the 4, and Y times 1 is Y. That goes in the numerator. Then we say, just like the 4 goes into 12, with what left over? 4 goes into 12 3 times. Y goes into XY how many times? X times. And X times 1 is X. When we put these together, we can't leave it like this. It's not simplified. Just like this isn't simplified. You can't leave it as 4 12ths plus 3 12ths. I'll yell at you and I'll mark major points off because you know how to add 4 plus 3. Well, you know how to add Y plus X, but we're going to put it in alphabetical order. Instead of Y plus X, it's X plus Y. They are not like terms, so you can't say X plus Y is XY. It's X plus Y is X plus Y because we don't know what X and Y are. But we write it over the denominator, which is XY. So the answer is X plus Y over XY. No, you cannot cancel and simplify the X's because it's just like if you came over here. Can we simplify 7 12ths? No, because that would be like saying, well, 3 plus 4, look at that. 3 plus 4 adds to 7. So I can cancel the 12 because 3 goes into 12. No, it can't because it's adding, right? That's how we got 7. Well, the way we got X plus Y was by adding. And you can't take out a 3 or a 4 out of 12 when you're adding them together, right? So that is the answer, X plus Y over XY. Okay, so let's look at some more ones, because they get more complicated. Here, we have 2 different denominators, 5 and 4. Same thing, but this time we have numbers in the numerators and letters. So we say 5 and 4, least common multiple, 20. 5 times 4 is 20. 5 times 4 is 20, right? Okay. So when we say 5 goes into 20 with what left over? 4. And 4 times 2 is 8. You should get that. 4 goes into 20 with 5 left over. And 5 times 3 is 15. 8 plus 15 is 23 over 20. Now we're going to model the same way. M and Y, they're different. They both go in the new denominator. So M and Y become M times Y, which is MY. So M goes into MY with what left over? Listen to what I'm saying. M goes into MY with how much left over? 5 goes into 20 with what left over? 5 goes into 20 4 times. 4 is left over. So 4 times 2. M goes into MY with Y left over. So it's Y times 3, which is 3Y in the numerator. Then Y goes into MY with what left over? M, or Y goes into MY, M times, because M times Y is MY. So Y goes into MY, M times M times 2x is just shove them together. 2xm or 2mx. Now, here we were able to add 8 and 15. Yeah. When we got 23, we can't simplify because we had to add to get them. 3y plus 2xm are not like terms. We can't add them, but we can shove them together and say 3y plus 2xm or 2xm plus 3y. I don't care. Over my. You cannot simplify this because these are being added and they're not, everything is, there has to be something in common everywhere, which we will get to. All right. Ooh, here we go. Now we have something like this. 1/3 plus 2/15. I just said something earlier about that. I said I think I used 5 and 15. All right, least common multiple of 3 and 15 is not 45. That's not the new denominator. It is 15. They both go into 15. Very important. We want to use the least common multiple. Very important. We don't want to use 45. So we convert 1/3 to 15ths. So 3 goes into 15 5 times. 5 times 1 is 5. And this stays the same. Then we add them. 5 plus 2 is 7/15. We can't simplify 7/15 because we got 5 and 2 added together. We can't take the 5 here and simplify this in here because that doesn't make any sense. Same way with here. So now we have 1 over x squared. And what does x squared mean? X times x, that's important. 1 over x squared is equal to 1 over x times x. It's 2 x's, not 3. 2 x's. So we're going to say, okay, 1 over x squared plus 5 over x. This is just like this one, except the 15 is the x squared. It's the least common multiple between x and x2, because we need how many x's in the bottom? We need 2 x's in the new numerator. So we say x squared goes in x squared one time, and 1 times 1 is 1 over x squared stays the same. Here though, x goes into x squared how many times? How many x's are there? 2. I have 1. How many are left? 1. You can write this right like this if you want to start. 1 over xx, 5 over x, 5x over xx. We don't want to simplify here because we need this common denominator. Okay? So x goes into x squared with an x left over. So x times 5 is 5x. See that? So 1 over x squared plus 5x over x squared. So we have to add them together. You could say 1 plus 5x, but I like to write it alphabetically, but I won't count off if you don't. So it becomes 5x plus 1. Can you add 5x plus 1? No, because they're not like terms. Or 1 plus 5x over the denominator, which is x squared. No, you can't cancel the x's because that's just like you can't cancel and simplify 7/15. You added them together to get there. You can't cancel. This one doesn't have an x. So the answer is 5x plus 1 over x squared. Okay. This is basically the same thing. So here's our denominator. 3x over y plus 2 over 3y squared. We need everything in the denominator, least common multiple. Everything has to be in it. So we need, which one is the larger? We need the y, and we need the 3, and we have y squared. So the largest one is 3y squared. We're going to practice these if you don't get this one. So y goes into 3y squared, this is 2 y's, with what left over? 3y. Because the y is already there, and there's a 3 and a y left. So 3y times 3x is 9xy. Then we say 3y squared, stays the same over 2. Now we shove them together. 9x, because we're adding fractions. 9xy plus 2 over 3y squared. That's your answer. No parentheses, nothing separate. That's your answer. You can't add them together. You can't simplify the fraction. Well, you could that one, but you can't do this one. The only thing I want to point out is if I put a 2 here, My common denominator would now be what? What's the common denominator, least common multiple between 2 and 3? 6. So instead of having a 3 here, I would have a what? A 6. Now that would change things, because then 2y goes into that 3. That would make that 6. That would make that 2 goes in that 3. That would still be 9, right? No, it wouldn't be 9. It would be 3. It would be, wait, did I mess up? Y goes, no, I didn't. 3 times 3, 3. No, it just happens to work out. This one would be different because 3 goes into that 6, 2, and 2 times 2 would be 4 here. This would be 4. I'm trying to show you that if you have coefficients, they have to have the least common multiple in there too. All right? All right, so you're going to write down 2 things you learned and 1 question you still have. Oh, wait. There's somebody who wants to say something. Oh, it's Baby Al. Hi, Baby Al. How are you doing? You're doing good? Is this a difficult topic? Okay. So do you have any advice? Don't simplify fractions with a plus sign in the numerator unless you have something in common with everything, which is coming. That's kind of confusing. Anything else? Take your time. Think. You are retraining your brain. Okay. Thank you for that bit. Okay. Am I goofy? Absolutely, I'm goofy. All right. I'll see you in class. Bring your notes.